Pearson's chi-square test, and Fisher's exact test in R. Let's start with Pearson's chi-square test. Let's revisit a slide from the video about Pearson's chi-square test part 1 introduction. Suppose we want to investigate whether a new vaccine effectively prevents influenza. To study this, we conducted a triple-blinded, randomized controlled trial, where the investigators, clinicians, and analysts remain blinded throughout the study. A total of 400 participants met the inclusion criteria and were randomized into two groups. 100 participants received the placebo and 300 participants received the vaccine. At the end of the study, 50 out of 400 participants contracted influenza. Therefore, the overall probability of influenza is 50 divided by 400 equal to 0.125. Because the study was blinded, it's unknown how many cases of influenza occurred in the placebo group and how many cases of influenza occurred in the vaccine group. After the label was opened, the following table shows the observed numbers. Based on the observed numbers, we can calculate proportions of influenza for the placebo group and for the vaccine group. Pearson's chi-square test. Non-hypothesis. Two groups are independent. All proportions of influenza are same between the vaccine group and the placebo group. Alternative hypothesis. Two groups are dependent. All proportions of influenza are different between the vaccine group and the placebo group. We can carry out Pearson's chi-square test and get a p-value. Based on the p-value from Pearson's chi-square test, we either reject the non-hypothesis or accept non-hypothesis. If the p-value is smaller than 0.05, which is significant at 0.05 level, we reject the non-hypothesis. If p-value larger than 0.05, which is not significant at 0.05 level, we cannot reject the non-hypothesis. Therefore, we accept non-hypothesis. You can download the dataset and R script used by this video. Go to this homepage, find the information on downloadable file on chi-square test. Afterwards, you can try everything out yourself. Let's go through Pearson's chi-square test in R. 4 boxes in these slides. The first and the third box are command lines in R. The second and the fourth box are output after running the command lines. Let's look at the first box. Because the original dataset was made in Stata, therefore the first line in the first box loads R package for which can read the dataset in several formats. The second line in the first box reads the dataset in state format into R. The third line organizes the dataset in table format. The fourth line asks R to display the table, which is shown in the second box. The first row in the second box is the placebo group, and the second row is the vaccine group. We can see 20 out of 100 participants contracted influenza in the placebo group, and 30 out of 300 participants contracted influenza in the vaccine group. If you add all numbers together, the sample size is 400. The command line in the third box carries out Pearson's chi-square test. The last line in the fourth box displays output from Pearson's chi-square test. Chi-square value is 0.8571, degree of freedom is 1, and p-value is 0.00829. In case you are interested in how to mathematically calculate the degree of freedom, chi-square values, and p-values, you can watch the video on Pearson's chi-square test, Part 1 Introduction, and Part 2 row and column-wise calculations. Below this video, you can find the link. These slides show how to display the expected and the observed numbers in R. Again, the first and the third box are command lines. The second and the fourth box are output after running the command lines. The first line in the first box assign the Pearson's chi-square test as a name CHI2. CHI2 in the blue box is the name I give. You basically can give any name you may wish. For me, CHI2 is easy to be recognized as chi-square test. The CHI2 in the second line is the same name I given. $sign in R extracts a specific part of output. Expected means extracts the expected numbers from the output, CHI2. Table in the second box displays the expected numbers in the Pearson's chi-square test. In case you are interested in how to mathematically calculate the expected numbers, you can find the link to the video below. CHI2 in the third box is the same name in the first box. $sign extracts a specific part of output. Observed means extracts the observed numbers from the output. Table in the fourth box displays the observed numbers in the Pearson's chi-square test. Conclusion: non-hypothesis is two groups are independent or proportions of influence are same between the vaccine group and the placebo group. Alternative hypothesis: two groups are dependent or proportions of influence are different between the vaccine group and the placebo group. Pearson chi-square value is 6.8571, p-value is 0.08829. Because p-value is smaller than 0.05, which is significant at 0.05 level. Therefore, we reject the non-hypothesis and accept the alternative hypothesis. That's the end of Pearson's chi-square test in R. Fisher's exact test in R. Let's revisit a slide from the video Fisher's exact test, Part 1 background. Suppose due to limited budget and time, instead of 400 participants, 40 participants were included and randomized into two groups. 10 participants received the placebo and 30 participants received the vaccine. At the end of the study, 5 out of 40 participants contracted influenza. Because the study was blinded, before the label was opened, it's unknown how many cases of influenza occurred in the placebo group and how many cases of influenza occurred in the vaccine group. After the label was opened, the following table shows the observed numbers. Based on the observed numbers, we can calculate the proportions of influenza for the placebo group and for the vaccine group. Validity of Pearson's chi-square test. The first and the third box are command lines in R. The second, fourth, and fifth box are output after running the command lines. Again, the original data was made in state. Therefore, the first line in the first box read the dataset in state format into R. The second line organizes the data as a table. The third line shows how table looks like. The first row in the second box is the placebo group, and the second row is the vaccine group. 2 out of 10 participants contracted influenza in the placebo group. 3 out of 30 participants contracted influenza in the vaccine group. If you add all the numbers together, the sample size is 40. The command line in the third box carries out Pearson's chi-square test. The last line in the fifth box displays output from Pearson's chi-square test. Chi-square value is 0.68571, degree of freedom is 1, and the p-value is 0.4076. If we pay attention to the first box, it's a warning message. Chi-square approximation may be incorrect. Let's find out why. The first line in the first box assigns the Pearson's chi-square test as a name CHI2. The same warning message in the second box. CHI2 $, and expected. It tracks the expected numbers from the output. As you can see, two expected numbers are below 5. If you revisit the video of Pearson's chi-square test, part 3, validity of Pearson's chi-square test. In this case, the sample size is 40 and the smallest expected number is below 5. Therefore, the Pearson's chi-square test is not a good approximation. Due to chi-square test is not a good approximation, exact test must be used. Fisher's exact test in R. Function Fisher dot test default is a two-sided Fisher exact test. P-value is 0.5835. Conclusions based on Fisher's exact test. Now, hypothesis: two groups are independent, or proportions of influence are the same between the vaccine group and the placebo group. Alternative hypothesis: two groups are dependent, or proportions of influence are different between the vaccine group and the placebo group. P-value equal to 5836. Because p-value is larger than 0.05, which is not significant at the 0.05 level. Therefore, we cannot reject the null hypothesis. In case you are interested in one-sided Fisher's exact test in R, we need to add alternative equal to less. The function will report exactly one-sided Fisher's exact test. If you are interested in the difference between two-sided and one-sided Fisher exact test, you can watch the video and find the link below. This is the end of the video about chi-square test and Fisher's exact test in R.